In this video, we're going to look at two questions on data. So, for question one, it says physicists sometimes use the approximation that light travels in a vacuum at a speed of 1 foot in 1 nanosecond. What is the percentage error in using this value? Okay, so what we know is that we can say the speed of light c is equal to 3 times 10 to the 8 meters per second. And then what we have to do is just convert 1 foot and 1 nanosecond into meters per second, and then compare it with this to calculate percentage error. So it's given over here that 1 meter is equal to this much yard, and 1 yard is equal to this much feet. So that is just, let's say, 1 times, first of all, convert it from a foot to meters, so that is divided by 3 to get the yard, and then divided by, so that's divided by 3, and then you divide it by 1.094 to get it into meters. And then we have to convert in from nanoseconds to seconds. So in this case, it is per nanosecond. So it's 1 over, and then over here we have 10 to the power of, this is minus 9. And then if we calculate this, so let's see, that is just 1 over 3 times 1.094, then times 10 to the power of negative 9. And that gives us, say, 3.047 times 10 to the 8 meters per second. And then we just have to calculate percentage error. So the percentage error will be the difference between these two. You can just say that's 0.047 times 10 to the 8 over the initial value, or the correct one, that is just 3 times 10 to the 8, and that is equal to, so the value minus 8, 3 times 10 to the 8, and that is just that's around like 1.6 percent. Okay, and that will be the answer to the first question. Now let's see the second question. Here it says, an experiment to measure the Planck's constant h. The following results are obtained. So it's in units of 10 to the power of minus 34 joules seconds. And then the first component of the question wants us to calculate the best estimate of Planck's constant. So I suppose the best estimate will be like the average of all these values, and the average of all these values, I would say like h avg will be equal to, I'm going to put these values into the calculator, so that's plus 6.67 plus, this is 5.7, and then 6.1, and then that's 7.2, and then 6.0, and 3.6. It's okay, so that's anomaly, and then 7.1, 6.6, 6.4, and then 6.7, and this is divided by, so how many values is this? This is 8, no, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's divided by 11, and it gives us, that's 3 points, I'm going to say 38, so 6.38 times 10 to the minus 34. Now let's see the second component question. So it wants us to calculate the uncertainty of h from your reading. And the uncertainty is simply just like plus or minus an amount, delta. And in this case, what we are given is a set of data. So in order to calculate uncertainty, what we want to calculate is the standard deviation of this series of numbers. So let's see. So the standard deviation, I'm going to use this symbol to indicate it. So it is just equal to the square root of the average of the numbers squared, and then minus the average of the numbers and then squared. So now let's see. This is just equal to, so the average of the number squared, that is just 6.65 squared, and then plus 67 squared, plus 557 squared, and then 61 squared, and then 72 squared, and then 60 squared, and then 3.66 squared, 6.71 squared, and then 66 squared, 64 squared, and the last one is 67 squared. And then you have to divide it by so 11 numbers, and that is just 41.42, like 2, and then minus the average squared, which is given as this from the previous question, and then squared. Now that is just 40.704, and that is just equal to let's say square root. That's square root of 41.422 minus 40.704, and that is 0.85. So the uncertainty is just so h is just equal to 6.38 times 10 to the minus 34 plus or minus 0.855 times 10 to the minus 34, and that will be the answer to the question.